Hello class, it's Mr. Kaplan here again. And this lesson we will still be focusing on solving equations, but this time we will be looking at multi-steps. So the steps that we'll be looking at here will have at least two different steps. And we're also going to see different things in terms of how we can solve equations when there are brackets and how we can solve equations when we have letters on both sides of the equal sign. So that's going to be something that's new as well. So that's what we're going to focus on in this particular lesson. So one thing you need to know about equations, again, ultimately is when you see an equation, okay, you always have to take a look at the letter and ask yourself, what steps do we need to perform in order to leave it alone? And just like we've been doing that we did in the previous lesson, we always have to perform opposite operations. Question is, what order do we need to do things? And that's what we're going to focus on in this lesson. So what you need to know about this here is that when you have a linear equation and it involves fractions, okay, you always want to get rid of it first by multiplying both sides by the denominator. However, one of the examples we're going to look at is we're going to learn how to get rid of fractions if we have two different denominators. Okay, so that's what that's the difference between what we have seen and what we're going to see in this particular lesson. Okay, so I've actually saved that one for the last because it's a little bit tricky. Okay, so first things first here, what I want to do here is just to take a look at problems involving multiple steps here, starting off with fractions. Now, you notice that for this question, okay, quite often people will have a hard time figuring out what you need to do first in order to isolate the variable. So you notice in this question here, what we have here is that the 2x, okay, is right there. So we need to leave that alone. So we need to figure out what we need to do in order for us to leave it alone. Now, we have a couple things that we have to factor in. We have to factor in that there is a number after the x there, and there's also a fraction. Now, notice that what we have here is that the letter and the number that's after it are all above the number 5 here. So guess what? Our first step here is to get rid of that fraction, okay? And the way we do that, remember, is that to get rid of any fraction, you always need to multiply both sides by the bottom number or the denominator. So by doing that, we're going to do exactly that. Now pay very close attention to the form here. Now, every time we multiply both sides by the denominator, I always show the reason why we do that. If you take a look at the left side, when we multiply both sides by the bottom number, which in this case is 5, it cancels it out. Now, this is a good time to actually, if you haven't done so already, is to do that step where when you're canceling out the numbers, because by canceling out the numbers, you notice what's left over. So now that the 5s are gone, on the left side, what's left over there is just the 2x plus 7, and then 5 times 3, that's going to give me 15. Okay, so now from here, we're still looking at the 2x there, so we're going to leave that alone. So the next move here, we're going to take this 7, okay, and since it's a positive, when it goes to the other side, it's going to subtract itself from the 15 that's already there. And then 15 minus 7, that's going to give me 8. Okay, and last but not least, okay, what we have here is a 2 and an x grouped together by multiplication. So the opposite of that, again, is you're now going to divide both sides by 2. Okay, and that cancels out the 2's on the left side, and that gives me x is equal to 4. Okay, so anytime you see two terms, okay, above a single number, that's how you know you need to get rid of the fraction first. Okay, so that's an important step for this particular question. Now, sticking to the topic of getting rid of fractions, the first step, we're actually going to do the same thing in the next example. Only difference again are just the numbers. So in this case here, notice that just like the previous question, we have a term with a variable or a letter, okay, and a number. This time it's separated by a minus sign, and it's all over -4 in this case. So just like the previous question, we're going to get rid of the fraction first by multiplying both sides by -4. Now again, when you multiply both sides by -4, okay, what we're doing here is we're canceling out the two -4's on the left side. Now, when we do that, notice what's left over on the left side is 7x minus 23, and then -4 times 11 gives me -44. Okay, next step here, you're going to now take the -23, okay, and we're going to move it to the other side, and then we're going to add it to the -44 that's already there. Now, we always move the number first because, again, what we have there is a term with a letter and a number, in this case separated by a minus sign. So we're going to take the negative 2023, move it to the other side, and add it to the negative 24 that's already there. And then negative 44 plus 23, that's going to give me negative 21. Okay, and last but not least, we're now going to divide both sides here by 7. Okay, to cancel out the 2 7s on the left side, and then negative 21 divided by 7, that will give me x is equal to negative 3. All right, so again, just like the previous question, in this case here, we got rid of the fraction first because the terms, okay, were both all over the denominator in this case. So always get rid of the fraction if you have terms that are above it, just like this one and the previous example. All right, so in the next set of examples here, we're now going to take a look at what happens when we have letters on both sides of the equal sign. Now, ultimately, the way I like to show this, since most of us read from left to right, is I always encourage people to keep letters to the left side and numbers to the right. Okay, so by doing that, we're going to break this step by step. Okay, and we want to organize our solution such that it's in proper form and it looks nice and neat. So since I want all the letters on the left side here, okay, that 5x on the left side stays exactly where it is. So in our first step, what we want to do is we want to take the negative 7x, okay, and we're going to move that to the left side. And when it does, it becomes positive and it adds itself to the 5x that's already there. So that's the first step. Okay, now for the next step, we want the numbers to the right. So since we have a 21 on the left side here, we're now going to move it to the other side and it becomes negative and it subtracts itself from the negative 15 that's already there. Okay, so what we have on the right side here will be negative 15 minus 21. Now, even though we only have one line there, we actually did two separate steps there. So we did two steps and just represented one line here. So again, letters to the left, numbers to the right. Now what we want to do in the next step is just to simplify. So on the left side, we have 5x plus 7x, which gives me 12x, and then negative 15 minus 21, that's going to give me negative 36. And since the 12 and the x are grouped together by multiplication, our final step here is to divide both sides by 12. Okay, to cancel out the two 12s on the left side. Okay, and then negative 36 divided by 12, that's going to give me negative 3. Okay, so again, anytime you see letters on both sides of the equal sign, just remember, letters to the left, numbers to the right. All right, so the next set of examples we're going to look at is we're going to look at what happens when we have brackets. Now, what we're going to revisit in this particular example is something that you are actually introduced to in grade 9, which is the distributive property, and that's going to be our first step. Now, remember when you are performing the distributive property, what you're doing there is you're taking the number that's in front of the brackets and you're multiplying it to the terms inside the brackets. So in our first step here, we're multiplying the 2 to the x and the 2 to the negative 4. So 2 times x gives me 2x, and then 2 times negative 4, that's going to give me negative 8. And then we're just going to finish this off. Now, just by getting rid of the brackets there by distributive property, notice what's remaining now is just a two-step solution. So again, in our first step, we're just going to leave the 2x where it is. So our first step here, to leave the 2x where it is, we're going to take the negative 8, and we're going to move it to the other side, and it's going to add itself to the 28 that's already there. Okay, and then 28 plus 8, that's going to give me 36. All right, and then for the final step, we're now going to divide both sides here by 2. Okay, to cancel out the two 2's on the left side, and then 36 divided by 2 will give me 18. Okay, so again, when you see set of brackets, get rid of them first by performing the distributive property. Okay, and then in most cases, okay, you will have, once you do that, then you will have no more than two or three steps to complete the question. Ultimately, in this question here, notice that after we got rid of the brackets, we had a two-step solution, which we saw in the previous lesson. Now, just to combine this example and the one before this one, okay, notice that what we have here, okay, we have brackets. We also have letters on both sides of the equal sign. Okay, now when we're doing this here, always get rid of the brackets first by performing the distributive property. Now just be careful with this one because what we're doing here is we're multiplying -3 to the x and -3 to the -5. So -3 times x gives me -3x. And don't forget, when you multiply -3 to -5, multiplying two negatives becomes a positive. So that will give me -3x plus 15. Okay, and then bring in the rest. All right. Now, the next step here is actually involves cleaning up. Okay, so if you take a look at the left side here, before we start moving things around, okay, as much as possible, always simplify terms that are common. Okay, so the next step here, I'm just going to gather the like terms, which in this case here are the two numbers on the left, which are 15 and 4. So what we have here is 15 plus 4, which gives me 19. Okay, so I've just gathered the terms just to clean things up. Now, relating this back to two examples ago, notice that we now have letters on both sides of the equal sign, okay, as well as numbers. So what we want to do in the next sequence of steps is we want the letters to the left, okay, and the numbers to the right. So starting off with the letters to the left, we already have the -3x on the left side there. So we're going to move the 8x, okay, and we're going to move it to the other side, and it's going to subtract itself from the -3x that's already there. So on the left side, what we have here is -3x minus 8x. Okay, and on the right side, we're going to take the number 19. We're going to move it from the left to the right. So since this is a positive 19, it goes to the other side, and it's going to become a negative and subtract itself from the 52 that's already there. Okay, and that's pretty much it. Now we're going to simplify this further. -3x minus 8x gives me -11x. Okay, and 52 minus 19 equals 33. And last but not least, we now divide both sides by the number attached to the x, which in this case here is -11. Cancels out the two -11s on the left side there, and that will give me x is equal to -33, -3. All right, so again, that question there is the combination of the what happens when we have brackets and what happens when we have letters on both sides of the equal sign. All right, this one here, it's going to be a little bit tricky here because what we've seen up until this point is anytime we saw a fraction, okay, we always got rid of a fraction by multiplying both sides by whatever the bottom number is. Okay, this one here is different. Notice in this question here, what we have here, okay, are two different denominators or two different bottom numbers. Now, what we want to do here is to multiply, okay, take a look at the fractions, and we're going to, in this case here, what we want to do is to multiply each term by what's called the least common multiple. Now, what a least common multiple is, okay, is a number that both of them actually have in common, okay? So when we're looking at the least common multiple, you probably know, how do we do this? How can we figure this out? Well, what you want to do here is to look at both numbers and see what numbers they have in common here. So I'm going to do that on the side. Okay, so starting off with 5 here, okay, if I list all the multiples of 5, okay, what we have here is 5, 10, 15, 20, okay, 25, etc. I can keep going, but I just want to get my point across. Now with 10, what we have here is 10, okay, 20, 30, 40, 50, and so forth. Now, the next question you have to ask yourself here as well, what is the lowest number that they have in common? Okay, that's what least common multiple is. So if you take a look at the numbers, you notice we have 5, 10, 15, 20, 25. Okay, notice that if you look at 5 and 10, the number that they have in common that's the same, that's the lowest, is 10. Now, I'm just going to throw another example here. Well, don't they have 20 in common? Yes, they do. However, when it comes to the least common multiple, you always choose the number that they have in common that is the lowest one. Okay, so that's going to be the least common multiple. In this case here is 10. Now, the next step is very important. You can see what we're going to do in the next step here with that 10. What we want to do with that 10 is to multiply each term there by 10, like this. So we're going to multiply the first fraction by 10, the second fraction by 10, and that's 7 by 10. Okay? Now, for the first fraction here, when we multiply that fraction by 10, Okay, those two 10s cancel out. Okay, and then what we have there is 3x. Okay, so that one there, pretty straightforward. It's the next one I want you to pay attention to. Okay, notice in the next one over here, okay, what we have here is 10 and 5. Now you're probably wondering what's that one that I placed beside the 10? Okay, that's just a reminder that when we're looking at least common multiple, this one there, I'm just putting it there just for a reference there, because when we multiply the two 10s over here and we look at the 10 table, notice it belongs in the first spot. Okay, so that's what happens there. So what happens with the 10 and the 5? Well, okay, the 10 and the 5s do cancel out. Okay, and a couple ways you can look at this is that when the 10 and the 5 cancel out, 10 divided by 5 gives me 2. Now, if you take a look at the right side here, the stuff I scribbled down here, notice that 2 also indicates the position that 10 is in. So again, depending on how you understand this, again, you can either understand as what happens when you multiply 10 divided by 5, okay, or you can see what position it is when you look at the multiples here, okay? So either way works. Now, 10 times 7 is 70. Now, in the next line, we're just going to rewrite it with what I have left over. So on the left side there, the 3x is just going to be on its own. And what's going to happen here, okay, is that this 2, okay, is going to multiply itself to the x, give me 2x. So the next line here will be 3x plus 2x is equal to 70, okay? And from here, we're just going to simplify. So 3x plus 2x, that's going to give me 5x. Now you can see here, now that we have 5x equals 70, we can now solve for the x by dividing both sides here by 5. Okay, and this will give us an x value here of 14. Okay. So again, when you're looking at the least common multiple, if you're not too sure what it is, look at the two bottom numbers and see what the lowest number they have that they have in common there. Okay. Now, for the next example, it's going to be a slightly tricky because in this example, I just want to start off with this one because notice that the least common multiple happened to be one of those two numbers there. However, in this case, we have a slight problem. We have 6 and 8. So for the least common multiple here, okay, what I want to do on the right side here is to look at both of these numbers and see what the lowest number they have in common. So let's start off with 6. So if you look at 6 for a moment, okay, what we have here is 6, okay, 12, 18, okay, 24, 30, 36, okay, and we can go keep on going, but we don't need to for this example. Okay, next one here we have 8, okay, 16, okay, 24, 32, and 40. We can stop there because we don't need to do any more than that. Now, in this question over here, you need to see what number they have in common. Well, if you look at the list here, the only number from our list that they have in common here is 24. Okay. Okay, notice that there's no other number that matches for both. So guess what? That happens to be the least common multiple. So it's going to be 24. Okay, so just like the previous example, now that we have a least common multiple of 24, we're now going to multiply each of those terms by the 24. Okay, this where it gets a little bit tricky. So we're going to take that 24, we're going to multiply it to the x plus 1. Okay, and we're going to multiply the 24 to the x minus 2. Okay, and we're going to multiply the 24 to the 6. Okay, so from here, what we want to do in this case over here is to now figure out what's going to happen with the numbers that are in front of the brackets there. Okay, so I just got to erase something so you guys can see what I've written down here, because I just don't want you to see again what the numbers are. Okay. All right. So when we do that, when the 24 and the 6, when you multiply the 24 to the first bracket, the 24 and the 6 cancel out. Okay, and then 24 divided by 6, that's going to give me 4. So that's what that 4 is. Okay, when I multiply the 24 to the second fraction, the 24 and the 8 cancel out. Okay, and the number that goes in front is 24 divided by 8, which gives me 3. All right, and then 24 times 6, that gives me 144. Now that we got rid of the fractions, okay, the next thing we want to do here is to get rid of the brackets by doing distributive property. So our first step here, we're going to multiply the 4 to the x. Okay, and the 4 to the 1. Okay, I'm just going to erase this for you guys. Okay, so from here, we're going to multiply the 4 to the x and 4 to the 1. Okay, and we're also going to multiply the 3 to the x and 3 to the negative 2, which gives me 3x minus 6, and bring back the 144. Now, before we start moving things around, what we want to do is clean things up on the left side here. So we're going to gather the like terms, starting off with the x's. So we're going to group the x's together. So we have 4x plus 3x. Okay, and we're going to group the numbers, which in this case here is 4 and minus 6. Okay, I've just rewritten them side by side just to show you what we're grouping together. I haven't changed any of the signs there. So 4x plus 3x gives me 7x, and then 4 minus 6 gives me negative 2. That's all equal to 144. Okay, so from now that we've simplified everything, notice what's left, what's remaining is an example of a two-step solution. So we're going to isolate the 7x for the first step by taking the negative 2. Okay, and since it's negative, when it goes the other side, it's going to add itself to the 144 that's already there. That gives us 146. And last but not least, we're now going to divide both sides here by 7, which cancels out the 2 7s on the left side. Now, when you put 146 divided by 7, it's going to give you a decimal. So guess what? We're just going to leave our final answer as x equals 146 over 7, because that's a fraction in lowest terms. All right, so that not only wraps up this lesson, but it also wraps up this chapter. So continue on working on the questions of the workbook or the textbook if you have it, and I will see you in the next chapter.